In this lecture, we're going to learn about copy constructors. And these are constructors that are called by the compiler to make copies if you try to construct a class object from another class object. To really learn about this, we're going to use a person class. We're going to set up a person class. It's going to have two sections. We're going to have a private section and we're going to have a public section. The private section is going to have a few member variables. We're going to have the last name, which is modeled as an std string. We're going to have the first name and we're going to have the age. In the public section, we're going to have a few constructors. We have the default constructor, which is not going to do anything. It's just going to initialize the member variables however they were declared. So the name is going to be empty, the first name is going to be empty, and the last name is going to be empty, and the age is just going to be a null pointer because the age is modeled as a pointer here. And this is by purpose because there are a few things I want you to see about copy constructors. Down here we have a few other constructors. We have one that only takes the last name, one that takes two parameters, the last name and the first name, and another that takes all the other parameters, which is going to initialize all our member variables here. We also have a utility function, which is going to print information about a person object. It's going to print the memory address where the object lives, and then we're going to have the last name, the first name, the age, and we can even print the address here. We can print information about our person object here. This is the point. Okay, now that we know about our class, let's talk about copies. We have a person object here. We're going to set them up and put this information here. The last name is going to be John, the first name is going to be Snow, and the age is going to be 25. And we can print information about this person. But we can create a copy of this person using the syntax here. And C++ is going to understand this. So we can say person, person2, and we want to create a person2 from person1 here. And if we do this, this is going to work. But it's not going to probably do what you expect because this is going to copy the member variables one by one from person1 to person2. So here is a simple illustration. We have person1 and we wanted to create a copy of person1 in another person, which is called person2 or P2 here. So what this is going to do is do a member-wise copy. So it's going to take the last name in person1 and copy that in person2. We're going to have a situation like this. It's going to take the first name in person1 and copy that in person2. We're going to have a situation like this. And then it's going to copy the age from person1 in person2. But remember, the age is a pointer. It's going to copy the address that is contained in this pointer and put that in person2 here. And this is going to give us a few problems as we are about to see in the next slides. And copying pointers directly like this is really going to give us problems. Let's explore this a little more. Here we have a simple example where we have our person1 and person2 here. And person2 is a copy of person1 as you see through the syntax here. So after we have our two persons created, suppose we want to set the age of person1. We do that through a set age setter that we have in person, which is going to set the age. And after that, if we print information, we're going to see that the age for person2 was also changed. Because what we really copied is a pointer. And the set age is going to dereference the pointer and change what is inside. And the change in person1 is also going to be in person2. So you need to be aware of this. This is a problem. And C++ is going to introduce this problem by default. Because C++ is going to copy member variables one by default. And it's going to really even copy pointers. So C++ does things this way because it generates a default copy constructor for you. And this is a constructor that is going to be used to do the copy we do here. So the syntax we use here is going to call a copy constructor. And in this case, we don't have a copy constructor in person. So the compiler is going to generate a copy constructor and use that. But that generated copy constructor is going to be doing member-wise copy from person1 to person2, and it is going to blindly copy the pointer for the age member variable. This is the source of all the problems we have down here of also having the age for person2 modified through changing the age of person1. Hopefully you see the problem here. Okay, so we have a problem here. How do we solve it? The first step is to try and see the problem and really prove this, for example, through the debugger. And right now, we are using a constructor that is generated by the compiler, so we can't really set a breakpoint there or really put any stdcout statement to see what is happening. But not to worry. It is possible to set our own copy constructor and use that to see information. We can even go further and disable the default behavior of even copying pointers and really customize it however we want. So we're going to do that. Here is our first attempt at setting up a copy constructor, and we're going to set it up like this. We're going to set up a constructor which is called person. This is part of the person class because of this scope resolution operator here. And then we're going to pass a parameter, which is another person, by const. Because we don't really want to modify it, we want to read from it. But notice that we are passing this by value. You need to see this. And then in our initializer list, we're basically going to be copying from the source person to our person object that we are building here. So the last name is going to be initialized with the last name from the source person. The first name is going to be initialized with the first name from the source person. And the age is going to be initialized with the age from the source person here. We are basically copying member-wise. We are doing the same thing the compiler has done for us. But this is going to be problematic because if you look here, we are passing by value. And this syntax is not allowed to be used in C++. The problem is, this could lead to an endless chain of copy constructor calls. So why is this? Remember, to create an object, we say something like this. We say person p2 and use p1 to build our person2 object. So when the compiler sees a call like this, it will know that it needs to call a copy constructor. And when it calls the copy constructor, it's going to see our copy constructor here. But it's going to see that something is passed by value. And to pass by value, you need to call the copy constructor, but the copy constructor itself is taking something by value. So we're going to keep trying to call the copy constructor, and this is going to be an endless chain of calls to the copy constructor, and this is going to end nowhere. So the designers of C++ saw this problem and they disallowed this syntax here to try and set up a copy constructor using an object that you pass by value here. So this is not going to work. If you do this, you're going to get a compiler error. What if we try and pass by reference? Okay, so the first attempt here is really bad. It's not going to work. If you're trying to use it, you're going to get a compiler error. But we can try and pass by reference. And that's what we have here. We are passing our person, source person by reference here, and it is by const reference because we don't really want to modify it. And we are doing the same thing we did in the last attempt in our initializer list here. Last name is going to be initialized with the last name of the source person. First name is going to be initialized with the first name of first person here, or source person, I should say. And the age is going to be initialized with the age of source person here. This is going to do what the C++ compiler does by default. It is doing member-wise copy, and we are blindly copying the age member variable here, and it is a pointer. So we're going to take the pointer address contained in source and just copy that in destination here, which is this age member variable here. And this is going to also be bad because we just copied a pointer, and if we modify one person's age, the change is going to be seen in the other person's age, and we don't really want that. Okay, so this is bad also, but it's not as bad as the first attempt, but this is still bad. We need to do better. What we need to do really is to not blindly copy pointers, but set up a new memory address in our new person object and just copy the value from the source object. And that's what we are doing here. So we are copying the last name and the first name as we did in the last two attempts. But notice what we do for the age member variable. Inside, we're going to set up a new memory location, and we're going to use the data from the source object to initialize this new memory location. And this is going to do what we want. It is not going to do a blind copy of the pointer. It is going to set up a new memory location in our new person object, and then we're going to use the data in the source object. And this is good. And if we try to change the person1 here, the changes are not going to leak into person2, and this is going to be good. Okay, so this is what you should do if you want to set up a copy constructor. You should pass your parameter by const reference as we do here. And if you have any pointer member variables, you shouldn't really blindly copy them. You should set up a new memory location in your destination object and then initialize that with the data from the source object, which is what we are doing here. We are dereferencing the pointer from the source object and we are grabbing the data inside and using that to initialize our age pointer here. And this is really good. Okay, so this is one way we have to set up a copy constructor and it is going to work, but it is also possible to delegate the work on another constructor. In the last lecture, we have learned about constructor delegation. We can use that with copy constructors, and we can do something like this. This is a copy constructor. It is going to take its parameter by const reference here, but notice that we are delegating the work to another constructor, which is going to take 3 parameters. So this constructor is going to use the data from our source object, and we're going to initialize the last name here. We're going to initialize the first name here, and notice that we are dereferencing the pointer and passing that data to our other constructor, because that other constructor is going to set up a new memory location and use this data here. Okay, so this is how you can delegate the construction from your copy constructor to another constructor that is going to do the heavy lifting for you. I realize all this can really be confusing, so we are going to head over to Visual Studio Code and do this step by step so that you can really see. Okay, here we are in our working folder. The current project is copy constructors. We're going to grab our template files and use those. We're going to paste those in. And we are going to open this in Visual Studio Code. Let's do that by dragging and dropping here. This is going to open our folder, and we need our person class that we can use to really learn about copy constructors. We're going to set up a header file, which is going to be person.h, and we're going to set up another file, which is going to be person.cpp, and we're going to put this in place. I am going to put in the code I have prepared before so that we can really be fast with these things. This is really a simple class. It is called person. We have our member variables. We have a private section and a public section. The private section is going to contain our member variables, and we're going to have our constructors here, which are going to be used to construct objects of person. We have a destructor, we have a few setters, we have a few getters, and we have a utility function, which is going to print information about our person object here. I am also going to put in the implementation for our person class, and then I am going to try and explain it a little bit. So we have a few member variables. Last name and first name are modeled as std strings, and the age is modeled as a pointer because I want you to see problems that might come up if you set up copy constructors and you have pointer member variables. So we really need this. So the constructors are really going to do nothing special. We have a one parameter constructor, which is going to delegate the work to another constructor, which is going to take 2 parameters. The 2 parameter constructor is also going to delegate the work to a 3 parameter constructor. And the 3 parameter constructor is going to construct our object using this initializer list here. Notice that the 3 parameter constructor is going to set up a new memory location because if you remember, the age is a pointer, so we need to allocate memory to store in the data. So that's what we do in the constructor here. We're going to say new int, and we're going to store in the data that is coming from the age parameter here, and we're going to set up our object like this. The problem with this is that it is really using strings by copy. And this is bad, so we should fix this either by using const string references or using string views. I am going to use strings that we pass by reference here. So let's fix this pretty quick. We're going to say const string by reference, we should say. And we're going to say const string by reference here. And const string by reference. Let's do this, and let's do that here as well. I think we have one left here. Let's do that, const string reference, and we could use these parameters in our constructors here. So let's go back in the CPP file and apply the same changes. We're going to say const string reference here. You see we have a few squiggly lines. let's say const string reference. We're going to fix this class a little bit. Const string reference here. Let's do this. You don't have to do this. You can just grab the file that will be attached to the resource section of this lecture, and you can use this class as is here. So let's say const here, and we're going to say const string reference. Let's do that. And const std string, and we're going to pass that by reference here. And we have our class. So again, we have 3 member variables and 1 is a pointer, and we have to make sure that the constructors that we use allocate new memory to be able to store data in this pointer here. This is what is really important for this class. So now that we have the class, we can head over in the main function and really use it. We're going to bring up the sidebar here and head over in the main function, and we're going to include our person class. So let's include person. You see that we have this available in the main CPP file here. We're going to take out what we don't need, and then we're going to set up a person object. We're going to say person p1, and we're going to put in John, and the first name is going to be Snow, and the age is going to be 25. I think this is what we used in the slides, so let's use this, and we can print information about this person. Let's do this, and we're going to build and see this printed out on the console. We can close this guy here. We don't need this for now. You see, the build is good. We can bring up a terminal to really play with us. And we're going to run Rooster. We're going to see that we have a person object living at this memory location. The last name is John, the first name is Snow, the age is 25, and the member variable for the age is living at this address here. This is the information we get from our printful function, which is living in our header file. Let's look at it and really see this. So it's going to print this information here, and it's going to print the value we have in the age pointer, and it's also going to print the memory location for this pointer here. And we do that by directly printing the pointer. Again, remember the age member variable here is a pointer, and this is key for what we are trying to do in this lecture here. So let's try and create a copy. We're going to go down here and create a new person, person2. We can say P2 here, and the syntax to create a person object from another person is passing it as a parameter. So we're going to pass P1 here, and this is going to do what we want. This is going to copy data from person1 and use that to create a new person object, which is going to be P2 here. And if we try to print P2, we're going to say printful. Let's see what we get. The first thing you should notice here is that the syntax here is working because of some heavy lifting that the compiler is going to do for us to allow for this syntax here to work. Let's build and really see this. We're going to build with GCC. We're going to see that the build is good. We can clear and run Rooster. Now we're going to see that person1, last name is John, first name is age, address memory is here, and you see that we have the same information in person2. Person2 is going to live at a different address because it is a separate variable, but what we have inside, the last name is John, the first name is Snow, the age is 25, but you see that the address for the age member variable is the same, so it was copied over. So suppose we have 3 slots in these 2 person objects. We have one for the last name, we have another for the first name, and we have another for the age. And we have the same things for person2 here, so let's put 3 slots here. And what the compiler is going to do if we set up a syntax like this, it's going to do blind copy of the member variable. So it's going to have what we have in the last name member variable, and it's going to copy that in the person2 object. It's going to copy what we have in the last name, and it's going to paste that into the person2 object. It's going to copy what we have in the age member variable, and it's going to paste that into the age member variable of person2. But remember, the age is modeled as a pointer in our class. And what this is going to do, it's going to copy the memory location which is contained in person1, and it's going to paste that into person2, and that's what we see here. We see the memory address in person1 for the age member variable is the same as we have in person2. So this is going to cause a few problems. So for example, if we try and modify person1, the changes are going to be seen even in person2 for the age. So for example, let's modify the age for person 1. We're going to set age, and we're going to set the age to 30, for example. And then we're going to print information for person 1 and person 2 after that. We're going to say P1 printful, and we're going to say P2 printful here. If we do this, we're going to see that the age for these two persons is the same, even if we really change the age for person 1. Let's put a little separator here so that we can see this on the terminal. We're going to put a few dashes. I think this is going to do. And we're going to build this. The build is going to be good. And if we run this, let's clear and run roster, we're going to see that the age for person 1 and person 2 have changed to 30. Because if we call set age, it is going to dereference the pointer and change the value inside. The thing is, we have the same memory addresses in these two persons object, and if you change either of these guys, the changes are going to be reflected in both of them. Let's look at how we change the age in person. I don't think we really looked at this in detail. Okay, so this is our set age method, and you're going to see that in the body we're going to be dereferencing the age pointer and assigning a value to it. And if we do this in main and change the age for one object and they happen to contain the same address, the changes are going to be reflected in both of them. And this is not what we want. What we would want if we copied a person object like this is for person 2 not to be affected by the changes we do in person 1. And the reason for this problem is because the compiler is doing blind member-wise copy. Again, it is copying the last name in person 2, it is copying the first name we have in person 1 in person 2, and it is copying what we have in the age member variable in person 2, and we have the same memory addresses here. So we need to fix this. But before I show you how to fix this, we should also show you how to see these things in the debugger. So for example, let's set up a breakpoint on line 14 here, and we can use a debugger to see these things instead of printing them out using the printful function here. So we can run our debugger. We're going to build our program. The build is good. We're going to give control to the debugger. We're going to hit this breakpoint here. And now we have our two person objects as locals in the main function here. So we can, for example, see the last name. Let's expand data plus here, and let's expand this a little bit. And you're going to see that the data in here is John for the last name. We can see the first name. We're going to see that if we expand data plus here, we're going to see that the last name is Snow. We can go down and look at the age. You see that it is a pointer. Okay, so let's go down to P2. We're going to see that we have the same information in last name and first name, but look at the age pointer here. It contains the same address both for person 1 and person 2. If you want to see the data inside, you can dereference the pointer and see the data inside. You can see that through the debugger. And this proves that we really are doing member-wise copy, and we are just copying the pointer. And this is going to be problematic if we modify one object. The changes are going to be seen in the other object. What we really need to do is to set up a new memory location in person 2 and use that to contain our data that we pass from person 1. So we're going to be able to do that if we set up our own copy constructor. So let's head over in the person class and set up a copy constructor. One attempt one might want to do to set up a copy constructor is to do something like this. They might come and say person, let's say copy constructor. They might say person and then pass another person by value. Let's say person, if I can type that. And we're going to call this source P for source person. And you see that we have a squiggly line, but let's go on and really finish this up. And then what you might do is go in your implementation file, because that's where we have the implementations for our person class. You might say person and say person. We can pass what we had in the header file. And then what you might do is initialize your member variables from what you have from the source person here. So we're going to put in a body, and then we're going to put our initializer list on the next line. I think that's going to be better. So we're going to say m last name. Is it called m last name? Let's see and see. It is called last name. So let's use that here. I don't want to go back and change that. We're going to say last name. It's going to be initialized with what is coming from the source person. So we're going to say source P and get last name. We have a function to give that. And then we're going to initialize the first name. It's going to be using whatever comes from source P. So we're going to get last name. We're going to do that. And then we're going to put a comma and initialize the age member variable. And we're going to use whatever comes from source person. And we're going to get age and use that to initialize our member variable. You see that this is really not working. And the reason is what we talked about in the slides. If you try to set up a copy constructor that passes parameter by value, this is going to cause a chain of endless copy constructor calls, because the copy constructor is going to want to call a copy constructor to set up a copy. And this is going to be bad. C++ designers saw that and they disallowed this kind of syntax here. So this syntax is not going to work. So let's comment this out, because some people are going to try and set up something like this. And let's say that this is bad and say potential for endless copy constructor calls. Okay, so we said that here. Let's close this a little bit because we need some more breathing space. So we can bring this back. Okay, now that we know that the syntax here is not going to work, we're going to set up another one, which is going to do member-wise copy. And we're going to set it up like this. We're going to pass by reference. So we're going to say person, and we're going to pass our parameter by const reference. So we're going to say const person reference and say source P here. This is going to be our source person. We're going to head over in the CPP file and reuse what we had done before. We can copy this. And we're going to put in our copy constructor, which is going to pass by reference and do member-wise copy. So let's say that here, we're going to do member-wise copy, and we need to call these guys as functions here. This is what the squiggly lines here are about. I think this is the same problem we had with our bad constructor here. So let's go back and comment this out because I want you to see the problem the compiler is going to show you. And we are going to uncomment this. Sorry for this. And we are going to comment out the member-wise copy constructor here. And we're going to uncomment this. But we're going to see that we get a squiggly line because this is not allowed syntax in C++. So let's change this to do a call to the getter functions. Okay, so our getters are called properly, but this is still not allowed. If we try to build our program, we're going to get a compiler error that is going to say that this is a syntax that is not allowed. The compiler error is not going to be really understandable. It's going to say invalid constructor. You probably meant const person by reference. You see the error here. This is a syntax that is not allowed. And if you're trying to use it, you're going to get a compiler error because it could lead to an endless chain of copy constructor calls. So we're going to comment this out again because you have seen the compiler error. Let's do that. Let's head over in the header file and comment this out again. And we are going to go down and uncomment our member-wise copy constructor. We're going to do this here. And now we have a constructor that seems to work. If we try to build with this constructor in place, let's see what we get. We're going to build with GCC. First, you see that we have errors. And what do we mean by this compiler error? Okay, so what do we have here? Let's go back. And this is not really commented out. Let's comment this out. And we're going to build again. Now you see that the build is good. And we have a constructor that is going to simulate the behavior we had with the constructor that was generated for us by the compiler. Because remember, before we set up our own constructors, the compiler was generating a copy constructor for us. And what the compiler generated was doing exactly what we see here. Member-wise copy, it was taking the last name from the source object and pasting that into our member variable for the last name. It was taking the first name from our source object and pasting that into our first name. And it was taking the age and pasting that into our age member variable. And remember, the age is a pointer, and that was the source of our problems because we had two objects for the person class that were pointing to the same age memory location. And this is really bad. And now that I look at this, I notice that we didn't use the first name here. We used the last name. We can fix this. We're going to say get first name. This is going to do what we want. But still, we're going to see the same problems we saw when we used the constructor that was generated by the compiler. But we can prove that our constructor here is being called by the compiler. Let's do that. We're going to say stdc out. I think we can say that. And we're going to say copy constructor called. We're going to see that our copy constructor is being used by the compiler. If I can type endl here. So this is good. Let's try and build and see what we get in our output. The build is going to be good. We can clear and run rooster. And we are going to see that our copy constructor is called. And the person object, which we created as P2 here, is going to have the same information we have in the first person object. The last name is going to be John. The first name is going to be Snow. The age is going to be 25. But we blindly copied the memory address in the age pointer and pasted that in our person object, which is P2 here. And this is going to lead to the problem we see here. If we change the age from person 1, the change is even going to be seen in person 2, and this is not what we want. So we need to fix this problem. And to fix this, we need to avoid blindly copying the pointer for the member variable for age here. We need to set up a new memory location and use that to store the information in our copy object. So we're going to change the copy constructor we have here. We're going to comment it out and do things right. So what we're going to do is comment this out, and we're going to set up another one, which is going to copy properly. We're going to say, don't blindly copy the pointer. And we're going to set up a copy constructor, which is going to do that. We're going to say person, and we're going to take a person object by const reference, because this is the syntax that C++ expects. What did we do? Const person by reference, and we're going to say source P. This is going to be our person. And we're going to go in the CPP file and comment out what we had here, because we don't want this. But I want you to keep this as a reference, and you need to know that this is really bad. It's not going to do what you want. And this is also bad because this is not supported. Let's say that this is really bad. Okay, I think this is expressing the level to which this is really bad. So let's go down and set up a constructor that is going to work, a copy constructor I mean. And we're going to say don't blindly copy pointers. So we're going to grab the constructor we had, which had a problem, and we're going to modify it a little bit and not blindly copy the pointer. So for the age member variable, we don't want to directly copy the pointer here. What we want to do is allocate new memory, and we can do that in our initializer list here. So we can say new int, and this is going to dynamically allocate space on the heap. And what we store in here is what we get if we dereference the pointer we get from the source object. And we can use this syntax here to do that. So if we do this, we won't be blindly copying the pointer. We will be setting up a completely new memory location to store the data in our copy object. So now that we have this in, we're going to try and build and really show you this. We're going to build with GCC. First, we will need to prove that this is going to work. So you see the syntax is really working. The build is good. We can clear now and run rooster. Now we're going to see that P1 is going to live at this address that ends in D30. P2 is going to live at this address that ends in CE0. And the age member variable for P1 is going to live at an address that ends in 2D0. And the age for the second person object is going to live at a different address that ends in 320. So we are doing things right here. We are using a completely new memory location to store the age for person 2, and this is what we want. If we look at the output after we modify person 1 and change the age to 30, person 1 is going to have the age of 30, and person 2 is going to have the age of 25, and this is really what we want. We have a copy constructor which is doing what we want. It is not doing blind copies of member variables, and this is what we want. This is how you can set up a copy constructor. So you now know how to set up a copy constructor, but I want you to know that we can reuse the constructor we have on top here. If you look, this constructor already knows how to allocate new memory for the parameter that you gave it. So for the strings, it's going to do a copy. Last name is going to be the last name that we pass in the parameter here. But for the age, it is going to make a new memory location, and it is going to store age param n. So we can really reuse it and avoid setting up a copy constructor that is doing all the heavy job here. So we can comment it out and use delegated constructors. We can do that. So we're going to say that here, delegate from the copy constructor. And the way to do that, we're going to have the same syntax we had, but we're not going to initialize the variables ourselves. So let's copy this and adapt this because I don't want to retype all this. So what we're going to do is take out all the initialization we're doing here, and we're going to delegate the construction from the copy construction to the construction we have on top here. So we're going to call it. What we're going to do is say person, and we're going to give it the parameters or the arguments, we should say. So we're going to give it the last name. We're going to say source person get last name. We can do that, and it is a function. We should call it. We're going to give it the first name. We're going to say source person, and we're going to get the first name. Let's do that, and it is a function. We should call it. Then we're going to give it the age. How do we get the age? We're going to dereference the pointer that comes from get age, and we're going to say source person get age. Now, not first name, it's get age. We're going to get the pointer, and then we're going to dereference that and pass the data to the other constructor that we have on top. So we still have a squiggly line here. I don't know why. Maybe C++ is confused. So what do we have here? Let's check this a little bit. We need to see. We have source B get last name, source B get first name, and we are dereferencing the pointer here and passing the data in. I think we need another set of parentheses. Let's see if that's what we need. Yes, we need another parenthesis in here, and then Visual Studio Code is going to accept this. So try to take a moment and really understand what we are doing here. The copy constructor is set up using the syntax that C++ accepts, but we're not going to initialize our member variables ourselves like we did in the last copy constructor that we did. We're not going to do any memory allocation ourselves. We're going to delegate all that heavy work to the constructor that we already have, which is constructing our objects here. And this is going to work. It is going to do what we want. Let's go back to the main function and build our program. We're going to see that the build is good. We can clear and run rooster. We're going to see that we have the exact same output. We have the data copied from person 1. We have the last name, we have the first name, we have the age. And if we change person 1 as we do here, in person 1 we're going to have the age to be 30, but person 2 is not going to be affected. And this is really good. This is what you should do. This is how you should set up your copy constructors. Okay, so this is really how you can set up your copy constructors in C++. And I don't think I really told you, if you set up your own copy constructor, C++ is no longer going to set up a copy constructor for you. It is going to call your copy constructor. And the copy constructors are another set of functions that the C++ compiler can generate for you if you don't have them in and they are needed. We have seen that the C++ compiler can also generate constructors for you. It can also generate destructors if you don't have any destructors in, but it can also generate a copy constructor as we have seen in this lecture, so you should really know that. And we should make sure that in our destructor we are releasing the memory that we allocated in our constructors. So let's really check that out. We're going to go in person CPP, and look, we don't have a destructor in place here. We have a destructor which is going to release the memory, and this is really good. We have to make sure that we are not leaking any memory here. So this is really all we set out to do in this lecture. I hope you found it interesting. Again, remember the syntax to set up a copy constructor, and remember to not do blind copies, especially if you have member variables that are pointers like our age here. We are going to stop here in this lecture. In the next one, we're going to see that if you store elements in an array, the compiler is actually going to make copies. And that's really interesting. And we're going to see that in the next lecture. Go ahead and finish up here and meet me there.